Welcome to MrCScience.com's video on moles in chemical equation, part 2, also known as Revenge of the Moles. We're going to continue our moles talk from our last video to kind of bring it in full circle so that you can understand how we're going to use moles for going on from now to the rest of the course. It'll be an integral part of pretty much every experiment, everything we talk about. Okay, you learned in the last few videos that a mole is 6.022 times 10 to the 23rd atoms or molecules. Mole is also related to as the AMU of the atom and molecule in grams. So if you take 6.022 times 10 to the 23rd atoms, you take the mass of all that, you'll find that its mass is equal to the AMU of that atom in grams. And so we kind of covered this. So let's show how we really use this in our equations. Let's use an example from your book. Let's say that chemists want to make a fertilizer called ammonium sulfate. Well, they'll start with ammonia, NH4, or NH3, sorry, ammonia. They'll add sulfuric acid, H2SO4, and that will give them ammonium sulfate, NH4, 2SO4. This type of reaction, you should know, is a formation reaction. So we're taking two smaller molecules, making a larger molecule out of it. Let's go ahead and balance this. Remember, we can't really treat ammonia and ammonium as a polyatomic ion, SO4. We can kind of treat it as a zone. But so let's see what we got here. We got one nitrogen. We got 3, and plus 2 is 5 hydrogens, and we've got 8 hydrogens. Now, anytime you've got an even number and an odd number, go and find that odd number and just start by doubling it. Okay, so that's going to give us 2 nitrogens, so we're going to need a 2 here. Then that's going to give us 6 plus 2 more is 8 hydrogens, and we've got 8 plus 2 is 16 hydrogens. Okay, I thought something seemed awry. Let's click here. Get rid of that 2 because we've got 2 nitrogens. We've got a nitrogen, 2 nitrogens. 8 hydrogens, 1 sulfur, or 1 sulfate, 1 sulfate. So we are balanced. So what we want to do, we recognize that this can stand for moles, either stand for number of ammonia molecules we have or moles of ammonia molecules we have, and so forth. So let's start with a little saying that some of my students have picked up and run with. Is we're going to go grams to moles to moles to grams. So let's say we've got 100 grams of ammonia, NH3. How many grams of ammonium sulfate will we get? Better write it out. How many grams of ammonium sulfate will we get? Okay, so in order, we can't relate grams to grams. So what we have to do is we have to convert this grams to moles. Then we can use our ratio of moles to go to moles of this required. Then we can do that to grams. So what we're going to do is we're going to start, and we always want to start with what we know, 100 grams of ammonium. Now what we want to know is how many moles of ammonium that is. So in order to do that, we have to know how many moles of, how much 1 mole of ammonium is. So 1 mole NH3 equals, well, we got 1 mole of nitrogen, 1 mole, plus we got 3 moles of hydrogen, 3 moles of hydrogen. So let's go ahead and take a look at our periodic table of elements, see what we got. Okay, so we find our nitrogen over here in column 5A, and its atomic mass is 14.0. So that means that 1 mole of nitrogen is 14.0 grams. Plus, we got 3 moles of hydrogen. We know the atomic mass of hydrogen is 1, so 3 times 1 or 3 grams. So altogether, 1 mole of ammonia weighs 17 grams. So let's grab this and give ourselves a little more room. Okay, so we take what we know, we put that over 1, and we multiply it by what we want to get rid of. We want to get rid of grams, and we want to get moles. We know 1 mole of ammonia is 17 grams. So if we take our 100 divided by 17, let's go to our calculator. 100 divided by 17 equals 5.9, or we'll say 5.9, keeping with significant figures. So 5.9 moles of ammonia is what we got. Okay, so now we've gone from grams to moles, and now we got moles of ammonia to moles of ammonium sulfate. So let's continue with what we know, 5.9 moles ammonia, NH3, not NH4, over 1 times, and we want to get rid of moles of ammonia, and we want to get moles of ammonium sulfate. So if we look at our equation, we know that 2 moles of ammonia give us 1 mole of ammonium sulfate. So we divide that by 9. 5.9 divided by 9 is what? 2.5, 2.95. So we're going to say 3.0 grams, or not grams, moles of NH of ammonium sulfate. That's a really poor looking S. There we go. Okay, so now we've gone grams to moles to moles. Now we have to go back to grams. In order to know how many grams we have to know how much 1 mole of ammonium sulfate is. So let's take a look at 1 mole. Oops. Thinking ahead. There we are. NH4 2 SO4. So that equals, what do we got? 2 times our moles of nitrogen plus we got 8 times our moles of hydrogen plus we just got 1 mole of sulfur plus 4 moles of oxygen. So let's see, our nitrogen was 14, so we got 2 times 14 grams plus 8 times 1 gram plus, let's look at our sulfur. Sulfur in our periodic table, 32.1 grams. 32.1 grams plus 4 times, let's look at our oxygen, I believe it is 16 grams oxygen. Equals, now let's just put that all in our calculator. So 2 times 14 is 28 plus 8 times 1 is 8 plus 32.1 plus 4 times 16 is 64 equals 132.1 grams per mole, or 1 mole equals that. So now let's go back to what we know. So we know that we got 3 moles of NH4SO, or sodium ammonium sulfate. So let's start with 3 moles NH4 2SO4 over 1. Multiply. Now we want to get rid of moles and gain grams, so we're going to put moles on the bottom. Put grams on the top so that the moles cancel out. And we know that 1 mole is 132.1 grams. So if we multiply 3 by 132.1, 3 times 132.1 equals, we get 396.3 grams. So that tells us that 100 grams of ammonia will give us 396.3 grams of ammonium sulfate. So again, going grams to moles to moles to grams. That gives us an idea. We're going to do this more and more as we walk through, so I want to just kind of close that off for you so we can do that almost anywhere. As we walk through, we'll do more and more of this. If you have any questions on it, feel free to drop me a line at mrc@mrcscience.com. Thank you.